So the next thing that we're going to talk about in section 3.3 is a way to measure variability. So again, kind of comparing this to section 3.1 and 3.2. 3.1 and 3.2, we were looking at symmetric data sets. When we were looking at our symmetric data sets, we used our mean and our standard deviation. Now that we are looking at different data sets, ones that are possibly skewed or have outliers, right? We just talked a little bit about our median and how we can use that to find our center. Right? So when we're going through and we're using a skewed distribution, we're going to use our median instead. And when we use our median, we're also going to use something called our interquartile range, which we're going to abbreviate with IQR. And so when a distribution is skewed and you are using the median to measure the center, an appropriate measure of variation is called the interquartile range. If we do not use the mean, then it does not make sense to use the standard deviation. So these guys belong in pairs. Mean goes with standard deviation. Our median is going to go with this interquartile range. Which again, as we go through, we're going to see it abbreviated with letters IQR. What our interquartile range does is it tells us roughly how much of the space the middle 50% of the data occupy. Right? So what we're looking at here, unlike the standard deviation where we were talking about 68% or most of it within one standard deviation of the mean, we're talking about the middle 50%. So that's what we mean by our interquartile range. So what we see here is we have just kind of a brief visualization. We go from our smallest data value on the left to our largest on the right. We can split this. In the middle is our median. Our median is also going to be labeled Q2, so our second quartiles. The abbreviation quart, right, means 4, so that's why we're splitting this into 4 pieces. So the median splits it in half. Then we have Q1 over on this side, which splits this half in half. And then our Q3 on this side, which splits this half in half. And if we look at this, then we have a total of 4 pieces. And then our IQR is actually this range from Q1 to Q3. Right? And so our IQR is actually that middle 50% that we see there. Right. So down at the bottom, this figure shows the weights in pound for a small selection of high school students. The medians and quartiles are shown by the vertical bars in the histogram. What can we tell about this data set from the histogram? All right, so looking at this first bar is going to be Q1. This is going to be Q2 or our median, and this is going to be Q3. So we will say, looking at this, that Q1 is about close to 120 pounds. We don't know exactly. Our median, which is also Q2, is close to, for these are going up by 5, that's about 135 pounds. And then Q3 over here is about 160 pounds. Right, so again, we have Q1, our median, which is also Q2, and then Q3. Right. So if we want to go a little bit further than this, we're going to say that half of the students weigh more than 135 pounds. Halfway less. And then we can also say the middle 50% of the students So again, the middle 50% having to do with our IQR, our interquartile range between Q1 and Q3. So the middle 50% of the students weigh between 120 and 160 pounds. All right, so that's what we mean by our inner quartile range, is the middle 50%. Depending on our data set, a few little other additional notes at the bottom. The inner quartile range, the IQR, may look large or small depending on the size and variation of the data set. The first quartile, Q1, divides the bottom 25% of the data from the top 75%. Our second quartile, Q2, which is the same as the median, divides the bottom 50% of the data and the top 50%, so half and half. And the third quartile, Q3, divides the bottom 75% of the data from the top 25% of the data. So that could also be something that we can see in our interpretations from here on.